Hello viewers, in today's session we are going to discuss another important and conceptual problem from derivatives. And in this session we are given a function f of x which is equal to 2 times mod of x minus 1 plus 3x mod of x minus 2, and we have to find the derivative of this function f of x at this point, that is 1.5. So here we observe that this function f of x is a combination of two mod functions. So here we have mod of x minus 1, and here we have mod of x minus 2, right? And we know that if we are given a mod function of this type, that is say a mod of x minus a, then this function say this is g of x, then this function is not differentiable at the point x is equal to a. And here we have mod of x minus 1, and here we have mod of x minus 2. So this function f of x is not differentiable at x is equal to 1 and x is equal to 2, right? So if we take the real number line, and if here we have x is equal to 1 and here we have x is equal to 2, then we have to find out the derivative of this function at this point, that is x is equal to 3 by 2, because 1.5 is equal to 3 over 2. So now let us first see the definition of mod function. Now mod of p is defined as positive p whenever p is greater than 0, mod of p is 0 whenever p is equal to 0, and mod of p is negative p when p is less than 0, right? So in this problem we are going to use this definition of a mod function to redefine this function f of x. Now x is equal to 3 by 2, it lies between 1 and 2. So we can now write 1.5, that is 3 by 2 is greater than 1, but it is less than 2. Right. So now using this definition of mod function, we can now write mod of x minus 1 is equal to positive x minus 1 when p is greater than 0. So if we take p is equal to x minus 1, then here when we take x minus 1 greater than 0, it implies x is greater than 1, and this point 3 by 2 is greater than 1, right? So we can use mod of x minus 1 is equal to positive x minus 1. And similarly here we can write mod of x minus 2 is equal to a negative. Here we'll use this definition or this part of the definition, that is negative of x minus 2 when x minus 2 is less than 0, right? And solving this inequality we get x less than 2, and here this x, that is 3 by 2, is less than 2, right? So in this problem mod of x minus 1 should be taken as positive x minus 1 when x is greater than 1, and our point of consideration is 1.5, and 1.5 is greater than 1, right? And mod of x minus 2 should be taken as negative x minus 2 when x minus 2 is less than 0 or x is less than 2. So our point of consideration 3 by 2 is less than 2. So now we can redefine this function f of x as 2 times. First we'll write mod of x minus 1 as positive x minus 1, that is simply x minus 1, and here we have 3x, and mod of x minus 2 is written as negative x plus 2, because here we can write minus x plus 2. So we can simplify 2x minus 2, and here we have minus 3x square, and this is 6x. So now we can write minus 3x square, 6x plus 2x is 8x, and here we have minus 2. So now we see that the function f of x is a quadratic function, and this is minus 3x square plus 8x minus 2. Now we can differentiate both sides. So we have f prime of x, and the derivative of x square is 2x, derivative of x is 1, and the derivative of 2 is 0. And here we can write minus 6x plus 8. So the derivative is a linear function, and we have to find f prime of 1.5. So we can now write f prime of 1.5 is equal to minus 6 times 1.5 plus 8. So substituting x is equal to 1.5 in this expression, we have now minus 9 plus 8. So this is minus 1. So the derivative of this function at this point 1.5 is equal to minus 1. So this is how, by making use of the definition of modulus function, we can first simplify the function f of x, and then we can find out the derivative at the required point. And here, this is very important to note that this function f of x is not differentiable at x is equal to 1 and x is equal to 2. Although this function f of x is continuous for all values of x belonging to the set of real numbers, but this function f of x does not have a derivative at x is equal to 1 and x is equal to 2. Hello viewers, in today's session we are going to discuss another important and conceptual problem from derivatives. And here in this session we are going to discuss this problem in which we are given a function f of x that is a combination of two mod functions. So here we have 3 times mod of 1 minus x minus 5 mod of x minus 3, and we have to show that this function f of x is strictly increasing function in this open interval, that is 2 comma 3, right? So here let us first see the definition of strictly increasing function, right? So we have already solved these type of problems in our earlier videos, and we have already discussed the concept of increasing and decreasing function in detail. But here let us quickly see the definition of strictly increasing function. Now see, if we have a function, say y is equal to f of x, right? And if the derivative of this function f of x it exists, then the function y is equal to f of x, which is defined in some domain, then this function is said to be a strictly increasing function if the derivative of this function is positive for all values of x belonging to the set of the domain, right? And here we write d for domain. So the derivative must be positive or it is greater than 0 for all values of x belonging to the domain. So we'll use this concept in solving this problem. So here we have the function f of x, that is 3 times 1 minus mod of 1 minus x minus 5 mod of x minus 3. So let us quickly redefine this function f of x, or we'll try to write this function f of x as a linear function of the form ax plus b by using the definition of mod function. So mod of p is defined as positive p whenever p is greater than 0. Mod of p is 0 when p is equal to 0, and mod of p is negative p when p is less than 0, right? So here we are given this interval because we have to prove that this function f of x is a strictly increasing function in this interval, that is when x belongs to 2 comma 3, or we can write x greater than 2 but less than 3. So now let us first express these mod functions using this definition of mod function. So we have mod of 1 minus x is equal to a positive 1 minus x whenever 1 minus x is greater than 0, or x is less than 1. And this is 0 when 1 minus x is equal to 0, that is x is equal to 1. And mod of 1 minus x is negative 1 minus x when 1 minus x is less than 0, that is x is greater than 1, right? So here we have x is equal to 2, and here we have x is equal to 3, right? And mod of x minus 3 can be written as positive x minus 3 whenever x minus 3 is greater than 0, that is x is greater than 3. And this is 0 when x minus 3 is equal to 0, that is x is equal to 3. And here we have minus x minus 3 when x minus 3 is less than 0, that is x is less than 3. So this is how we can define mod of 1 minus x and mod of x minus 3. So now here we have the interval x greater than 2 less than 3. So we have to define mod of 1 minus x and mod of x minus 3 in this interval only. So now see, here we have mod of 1 minus x, and mod of 1 minus x is equal to negative 1 minus x when x is greater than 1, right? So we'll define mod of 1 minus x is equal to negative 1 minus x when x is greater than 2 and less than 3. And mod of x minus 3 is defined as the negative x minus 3 when x is less than 3, right? So here we have x less than 3, so we can now write mod of x minus 3 as negative x minus 3 when x lies between 2 and 3. So now let us substitute these values in this function f of x. So we can write f of x as 3 times minus 1 minus x, and then here we have minus 5, and here we can write minus x minus 3 because mod of 1 minus x is negative 1 minus x, and mod of x minus 3 is negative x minus 3. So let us simplify. So we have 3 times minus 1 plus x, and here we have minus 5 minus x plus 3. So we can now write minus 3 plus 3x, and here we have plus 5x, and here we have minus 15. So we can now write 5x plus 3x is 8x, and minus 3 and minus 15 is minus 18, right? So our function f of x is now equal to 8x minus 18, which is of this form, that is ax plus b. So this is a linear function. So let us differentiate f of x. So the derivative f prime of x is equal to d by dx of 8x minus 18. So here we can see that the derivative of x is 1, the derivative of 18 is 0, so we have simply 8. So the derivative of f of x, that is f prime of x, is equal to 8, and this is a positive quantity, right? So f prime of x is always greater than 0 for all values of x belonging to the domain. So here f prime of x is always going to be positive in this interval, that is x belonging to 2 comma 3, right? So this shows that the definition of strictly increasing function, that is f prime of x is greater than 0, is satisfied by this function in this interval, that is x belonging to 2 comma 3. So f prime of x is always going to be greater than 0, because 8 is a constant and it is greater than 0 for all values of x belonging to this interval. Hence this function is a strictly increasing function in the given interval.